welcome all in today's class. As we have discussed the matrix chapter, in matrix there were so many types of matrix, and one type was square matrix. The square matrix is called that matrix in which the number of rows is equal to the number of columns. Let A be any matrix, then if we write like this 1, 2, 3 and 4, it has 2 rows and 2 columns, so its order is 2 by 2. Means we can say this is a square matrix. Now we come on today's topic, determinants. Every square matrix associates with a unique number. That number may be real as well as complex. So what is determinant? Determinant is a number to which every square matrix associates, as number may be real as well as complex also. So we can define determinant as to every square matrix A equals to Aij of order n, we can associate a number real or complex. Called the determinant. Called the determinant of matrix A. It is denoted by that A or determinant of A or del. So this is the determinant. So what we come to say, determinant is a number that associates with every square matrix. Now we come on its value. The determinant of every square matrix is unique. We can understand this one by another definition of the determinant. Determinant may also be understood with the help of function, as determinant is a function from m to k, where m is the set of all square matrices. And k is the set of numbers. Real or complex. So f is a function from m to k such that f of a is equal to k for every a belongs to m and k belongs to k. Means we can say determinant is a function from m. Okay. Now we come on the definition of function. As the definition of function says, function is a relation in which every element of first set has its unique image in second set. Means फर्स्ट सेट से हम ले रहे हैं स्क्वायर मैट्रिक्स, इसका मतलब हर स्क्वायर मैट्रिक्स एक नंबर से एसोसिएट होगी और नंबर से भी जो एसोसिएट होगी वो यूनिक नंबर होगी। इट मीन्स कि हर स्क्वायर मैट्रिक्स एक यूनिक नंबर से एसोसिएट होगी। वो नंबर रियल भी हो सकती है, वो नंबर कॉम्प्लेक्स भी हो सकती है। इन दिस वे we can understand determinant is a function also. Determinant possesses only for square matrix. As we see how we find the determinant of any square matrix. So we are discussing first determinant of a square matrix of order 1. Suppose A is any square matrix, its element is 2, its order is 1 by 1. So A is a square matrix of order 1, its element is 2. If we want to find the determinant of this matrix, then its determinant will be its element itself. Means determinant of A is equal to. So for every square matrix of order 1, its determinant is same as its element. Now we come on determinant of order 2. Like this. This is a determinant A. Its order is 2 by 2. A is a square matrix, and now we want to find the determinant of A. It is denoted as that A. We have to be careful here. This is not modulus. This is determinant A. So its value may be negative also, negative, positive, any real number or any complex number. So we should not be confused that every time its answer should be positive. Its answer may also come negative also. So the process for finding the determinant of order 2 is that first multiply the diagonal elements 1 into 4 minus multiply the off diagonal elements 2 into 3. So this is 4 minus 6. So its value is minus 2. So determinant of A is equal to minus 2. Like this, we can find the determinant of every square matrix of order 2 by 2. Now we come on the square matrix of order 3. For a square matrix of order 3, let us have an example. Let order 3. That is another square matrix of order 3 by 2. Its elements are 1, 2, 3, 4, 5, 6, 7, 8, 9. Clearly you can understand its order is 3 by 3. So we can say this is a square matrix of order 3. Now we are going to find its determinant. So determinant of this matrix will be found out by breaking it into one order less, means order 2. Firstly convert it into order 2, then find its determinant. Like this. we will write here 1, and then as you know 1 is the element of first row and first column. In matrix we have understand its representation as it is called A11, A12, A13, A21, A22, A23, A31, A32. This element is A11. This is of first row and first column element. So for finding out its determinant, after writing this element, we have to hide the elements of first row and first column. After hiding the elements of first row and first column, the remaining element will be written like this: 5, 6, 8. Now put a negative sign here. I'll tell you why this negative sign is coming here. Actually, all the signs of this matrix are alternate. If this is positive, then this will be negative. Positive, negative, positive, negative, positive, negative, positive. How they are coming like this? We can check the sign by adding its subscripts, as this is the element A, I, J. And we take minus 1 raised to the power I plus j. If the sum of these two is even, then its sign will be positive. If it is odd, then its sign will be negative. So here you can see this is the element A12, and the sum of 1 and 2 is 3, that is odd. So minus 1 raised to the power 3, that is minus 1. That's why we are putting here the negative sign. So after putting the negative sign, we will write the element here 2. Now 2 is the element of first row and second column. So after writing 2, hide the elements of first row and second column. What are the remaining elements? 4, 6, 7, 9. So write them 4, 6, 7, 9. Then plus 3. Then hide the elements of first row and third column. So remaining elements are 4, 5, 7, 8. Now by the process of determinant for finding the square matrix of order 2, firstly multiply the diagonal elements minus off diagonal elements. So we will write here 1, 5 into 9, 45, minus 40, minus 2, 36, minus 40, plus 3, 32, minus 35. So we will write here minus 3, minus 2 into minus 6, plus 3 into minus 3. So here is minus 3, plus 12, minus 9. Minus 3 minus 9, minus 12 plus 12, so its value is G. So the value of determinant A is G. In this way, we can find out the determinant of any square matrix of order 3 by 3. Now let us talk some properties of this. As we have expanded this matrix along first row, but every time is it not necessary that every time we have to expand it along first row. We may find out its determinant by expanding along any row or any column. The value will be same. So it depends on the matrix to which respect we are going to expand it. As you have seen here, firstly we are writing the element, then writing the determinant of order 2. Means this element is being multiplied with this determinant. What will happen if this is 0 or this is 0? This whole will become 0. This whole will become 0. Means calculation will be more easy. So we have to take care when we are going to expand the square matrix for finding its determinant. We must expand along that row or that column in which the number of zeros are existing, in which some zeros are existing. So, for finding the determinant of a square matrix 3 or more than 3 order, the process will be same. First we will convert it into order 2 by 2, then we will find its determinant. So determinant can be found by expanding along any row or any column. Then again we are talking some of its properties, as if we talk about the matrix, then in matrix, if two matrices are equal, then we compare their corresponding elements and we can find out the value of any unknown value. Like this, if this is the matrix A, here is x 2 1 7 and it is -1 2 1 7. If both these matrices are equal, then we can easily tell the value of x, means the value of x is -1. But will it same for determinant also? If we are taking the determinant of these two, then can we also compare x with -1? To see its answer, let us talk its comparison of two determinants. So let us take that we have the same example. X 4 9 x determinant is equal to 1 2 1. Both of these determinants are equal, then what will be the value of x? To find out the value of x, first thing we have to keep in our mind, we cannot compare the elements of two determinants. The whole determinant will be compared, means it will be compared after finding the values of these determinants. So let us find its value. For expanding the left side determinant, firstly we will multiply diagonal elements, means x square minus 36 equal to 2 minus 2 is 0. X square minus 36 equal to 0. X square equal to 36. So x is equal to plus 6. So the value of x may be plus 6 or minus 6. This is the way to find out the value of any unknown in any determinant. Now one more thing, if A is a square matrix 1 2 3 4 and B is another square matrix 2, 4, 6, 8. Are you seeing some relation between these two? Here, the elements of B are double the elements of A. So we can write B is equal to 2A. Matrix B can be written like B equal to 2A. Let us see about its determinant. What will be the value of the? So if I am finding the value of determinant A, then determinant A will be 4 minus 6. That is minus 2. The value of determinant B, this is equal to 16 minus 24. So that is minus 8. मीन्स कि अगर हम डिटर्मिनेंट ए और डिटर्मिनेंट बी को देखें तो डिटर्मिनेंट बी डिटर्मिनेंट ए का डबल नहीं है. मीन्स मैट्रिक्स की तरीके से हम डिटर्मिनेंट को हैंडल नहीं कर सकते. सो व्हाट विल बी द प्रॉपर्टी हियर? एज डिटर्मिनेंट ऑफ ए इज इक्वल टू determinant here minus 2 and determinant of B is equal to minus 2. From here you are seeing B is equal to 2A. Then determinant of B will be equal to 2 raised to the power 2 into determinant of B. Means common property will be determinant of B is equal to k raised to the power n into determinant of k raised to the power n into determinant of where n is the order of a square matrix and K is an easy. So in this way we have established